In the name of Almighty God, I am Master Sankasha, and today I want to talk about chemical reaction engineering module in computer multiphysics simulation software. Additional source. Use the additional source node to add an additional source term on a domain. To add an additional source term to a size interval, intervalue, or expression in the corresponding text field. Fluid section. The fluid node is added by the default and is used to model the mass transfer in a fluid with the size-based population balance interface. The node adds all equations governing the diffusive and convective mass transport of the population. It also provides inputs for material properties. The fluid node is not available in zero dimension. Model input section. The temperature model input is always available. Select the source of the temperature to enter a value expression for the temperature. Select the user-defined option. The user-defined option is always available. Convection section. Under convection, the velocity field for convective mass transfer can be specified. Select the source of the velocity field from the velocity field list user for user-defined intervalues expression for the velocity field components in the input fields. This option is always available. A fluid flow interface can be selected as the source of the velocity field. Diffusion section. In the diffusion section, select the source of the diffusion from the list. It can be set to from material user defined or defined individually. For from material, select the material from the material list to access diffusion coefficients defined within that material. Select the diffusion coefficient from the diffusion coefficient list. If you don't select the material with diffusion coefficient, you can enter a value expression in the diffusion coefficient field. The value expression can be a scalar value for isotropic diffusion or a tensor describing anisotropic diffusion. Select the appropriate tensor type: isotropic, diagonal, symmetric, or full. When the diffusion source is set to diffuser, define intervalue expression in the diffusion coefficient field. When this option is selected, the text field also accepts an expression written as a function of the particle size pop L. Select the define individually to set the diffusion coefficient for each discrete size interval individually. In full section, use a full node to specify the number densities of different sizes at inlet boundary. If you want to specify the number densities of only certain size intervals, this can be done using the number densities node. Instead, the inflow node is not available in zero direction and dimensions. Population number density. Select the user defined from the list to enter a value expression that is applied to all size intervals. When this option is selected, the text field also accepts an expression written as a function of the particle size pop S. Select define individually instead to enter a separate value expression for each size interval. Boundary condition type. The option number density constraint constrains the number density values on the boundary. The other option, flux tank verts, prescribes the total flux at the boundary defined by an upstream number density and fluid velocity at the boundary. Constraint settings. To display this section, click the Show More option button and select Advanced Physics options. You can find details about the different constraint settings in the section constraint section. Reaction terms in the Council Multiphysics Reference Manual. Initial values. The initial values node specify the initial values for the number densities of the different size intervals. These are used as an initial guess for a stationary solver or as initial condition for a Gaussian simulation. Population number density. Select either user defined or defined individually from the list. When user defined is selected, enter a value expression for the initial value of the number density to be used for all size intervals. When user defined is selected, the text field also accepts an expression written as a function of the particle size pop L. Instead, when defined individually is selected, the number density can be entered for each dependent variable individually with a unit 1 per quadratic meter. To instead specify number densities independent of the interval length, select define number densities independent of interval length. The number densities then have the unit 1 per cubic meter. No flux. The no flux node is added by default. Node is the default boundary condition and exterior boundaries. It should be used on boundaries across which there is no flux. The condition is applied as follow. Convection setting. By default, the no flux node prescribes a vanishing diffusive Flux at the boundary. This is appropriate when the relative convective velocity at the boundary is zero to include the convective flux. Select include in the convection section. When including convection, the total flux is prescribed instead and the no flux condition is as follows. The no flux node is not available in zero dimension. Now I want to go through the number density. The number density node adds a boundary condition for the number density at the boundary. The number density node is not available in zero dimension. Population number density select user defined from the least to entire value expression that is applied to all size intervals. When this option is selected, the text field also accepts an expression written as a function of the particle size pop L. Select define individually instead of define number densities individually for each size interval. For define individually, select the checkbox for the number density of a specific size interval and interval value or an expression in the corresponding field to specify the number density. Constraint settings. To display this section, click the Show More option button and select Advanced Physics options. You can find details about the different constraint settings in the section Constraints Reaction Terms in the Consumer Physics Reference Manual. Outflow section. Use the outflow node to specify an outlet boundary where transport out of the model domain can occur. It is assumed that convection is the dominating transport mechanism across the boundary and diffusive transport can be ignored. That is as follows. The outflow node is not available in zero dimension. Now I want to go to the vapor-liquid equilibrium multiphysics interfaces. The vapor-liquid equilibrium interfaces are predefined multiphysics interfaces available in the chemical reaction engineering module that solve for mass transfer and fluid flow of gas mixtures in contact with liquids. Selecting a vapor-liquid equilibrium multiphysics interface under the chemical species transport, then select vapor-liquid equilibrium branch of the model results a fluid flow interface and a transport of concentrated species in vapor interface are added to the model builder. In addition, the multiphysics node is added, which includes the multiphysics coupling feature reaction flow. The reaction flow feature predefines and controls the coupling between the separate interfaces in order to facilitate easy setup of models. The transport of concentrated species in vapor interface includes three dedicated boundary features for vapor transfer. The vapor inflow feature can be used to prescribe inflow conditions resulting from an upstream system involving a liquid. The vapor-liquid interface feature can be used to model condensation and evaporation to or from a gas mixture in contact with a liquid. In the case of the liquid with multiple components, the vapor-liquid solution interface can be used to also model the composition in the liquid section. In this section, you can also go through the laminar vapor flow, laminar two-phase flow, turbulent flow, epsilon, turbulent flow, omega, turbulent flow, SC, turbulent flow, Lau, Reynolds, epsilon. Now I want to go through the laminar vapor flow. The laminar vapor flow version of the vapor-liquid equilibrium multiphysics interface is used to simulate evaporation and condensation to or from a vapor-liquid interface. The interface combines the transport of the concentrated species in vapor and the laminar flow interfaces. The reacting flow multiphysics coupling, which is added, automatically couples vapor mass transport and fluid flow. Thank you so much for watching my tutorial video until the end. Today is 17th of May 2026. Time is 8:18 a.m.